today we're going to talk about an inscribed angle and what that means. If you go back to the very beginning of circles, we talked about inscribed squares within a circle. So remember, if it's inscribed, it has to be located inside the circle. So inscribed angles is what we are looking at in this section. So just a brief review of what we've learned so far pertaining to circles. We have the circle and we have a central angle. If I call that center X and then I have arc YZ, we learned that the measure of the angle is the same thing as the arc measure, but it has to come from the central angle. So here if I said that the measure of YXZ is 85 degrees, remember this is a central angle. That is so very important that we recognize that's coming from the center. So if it's 85 degrees, then we also know that the arc across from it measures the same, which is 85 degrees. But it has to come from the center. If it doesn't come from the center, then we're going to have to use something else, which is what we're doing today. So in today's notes, going back to inscribed, that should say angles, we're looking at a section that involves inscribed angles. So in your book, it tells us that an inscribed angle has a vertex on the circle. So it has a vertex on the circle, whereas a central angle, it was where? It was in the center. So we have this circle and the vertex is on the circle. That means it's going to be a point out here somewhere on this circle. So I'm just going to call it point X. Okay, it has a vertex on the circle and the sides contain chords, or the sides are chords. Of the circle. So I'll show that. Now I have the angle ZXY. I ask you, is that a central angle? It is not a central angle because it doesn't come from the center. To come from the center, it would be a central angle. This is not. This is an inscribed angle. It has a vertex on the circle and the sides are chords of the circle. So I have chord XZ, I have chord XY, and they meet at point X, and it forms the inscribed angle ZXY. So an example of an inscribed angle here would be angle ZXY. We have another definition called an intercepted arc. What is an intercepted arc? Well, your textbook says it has endpoints on the sides of an inscribed angle. So we have the endpoints. On the sides of an inscribed angle. But that's not all. It lies in the interior of the inscribed angle. Inside of it lies on the interior of the inscribed angle. So it's inside this angle. So the intercepted arc here, the arc that has sides of an inscribed angle, it has to lie within it. This arc here would be arc ZY. So arc ZY is an example of an intercepted arc. It has endpoints on the sides of the inscribed angle, and it lies in the interior of the inscribed angle. You might say, well, why can't ZXY be an intercepted arc? It is an arc. I'm not saying it's not an arc, but it's not an intercepted arc, because the intercepted arc has to fall within the inscribed angle. So the intercepted arc here is ZY. Okay, so with that, we have a theorem. It's called the inscribed angle theorem, and that's going to help us find the values of those intercepted arcs. So the inscribed angle theorem says, if we have a circle, we have an intercepted arc from the inscribed angle. There's no reason that that's dotted. I just haven't changed the line. But here's this angle ACB. That is the inscribed angle. So ACB is inscribed. And that's important for us to know. Inscribed, its vertex point is on the circle. Then the measure of the angle equals 1/2 the measure of its intercepted arc. The measure of the angle equals 1/2 the measure of its intercepted arc. So for example, if I look at this as angle 1, the measure of angle 1 is half of the arc measure if it's coming from the circle. So the measure of angle 1, or ACB, however you want to look at it, is equal to half of the arc measure AB. So the measure of angle 1 is equal to 1/2 of the measure of arc AB. So if this is 40, then from A to B has to be 80. Okay, let's go the other way. If AB is given, the arc AB, then we know that that's 2 times the measure of the intercepted angle, the inscribed angle. So if I tell you that this time, hey, let's say that AB is 100 degrees, that arc AB is 100 degrees, then the measure of angle 1 would be 50 degrees. It's 1/2 of that angle. So we would have to say it would be 50 degrees. Let's look at some examples of inscribed angles. We have a circle, and then we have the inscribed angle MPN. And we also have the inscribed angle PNO. So we're told that arc MN is 70 degrees. We're told that PNO, the angle, that inscribed angle, is 56 degrees. So we have to find each measure. The first one, I'm asking you to find the measure of angle P. Well, angle P is here, MPN. If we know that the measure of arc MN is 70, remember that the inscribed angle is half of that intercepted arc. So if MN is 70, then what is half of 70? Would be 35. So the measure of angle P would be 35 degrees. Okay, the next part, we're asked to find the measure of arc PQ. Well, PQ is here. This is the intercepted arc. It has to lie within the inscribed angle. The inscribed angle is 56 degrees. So I would take 56 degrees because it's the angle measure, and multiply it by 2. So 56 times 2 is 112 degrees. The next theorem, we are told that if two inscribed angles of a circle intercept the same arc, this is my circle, and I have two inscribed angles. So here's an inscribed angle, and then here is an inscribed angle. Well, they're intercepting the same arc. They're intercepting this arc right here. So no matter what this value is, if this is 100, then this has to be 50, and this has to be 50. If this is 45, then this has to be half of 45 and half of 45, because they're intercepting the same arc. So the theorem says if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So let's look at an example of that. We're given the inscribed angle STV and SUV. And we're told that this angle here is 3x minus 5 degrees, and this angle here is 2x plus 15 degrees. Well, they come from the same arc, so therefore the two angles are congruent. So I would just simply say 3x minus 5 is equal to 2x plus 15. I'm asking you to find the measure of angle t. So finding x is not enough. Once we find x is 20. We subtract 2x, add 5, we get x equals 20. We're not done. We have to find the measure of angle t. Angle t, the measure of angle t is 3 times 20 minus 5. So 3 times 20 is 60, minus 5 is 55. So the measure of angle t is 3 times 20 minus 5, which is 55 degrees. Alright, next example. We still are looking at the circle. If I have an inscribed angle that intercepts the diameter of the circle, so for example, here, we have the diameter of a circle, and then the angle that is inscribed is formed through that diameter of the circle. So I know that from here all the way to here is 180 degrees, right? Because this is the central angle. But I need to find, here I'm going to say we're looking for 4x plus 2 degrees, and we have another angle here, which is 9x minus 3 degrees. So if you look at this, the theorem really does make sense, because we have an arc that has been formed by the inscribed angle. And that inscribed angle is part of the diameter. Well, the whole thing from this endpoint to this endpoint based off of this inscribed angle is 180 degrees. So all the way around this circle is 180 degrees. 180 degrees, 180 degrees. It's a semicircle, all the way around half the circle, I should say. So wherever the arcs start, remember, if half of this is half the circle is 360 and this is 180, then from there, that inscribed angle, this angle right here that I've just traced with the pink, has to be 90 degrees. So now I can find x by saying 4x plus 2 plus 9x minus 3 plus 90 is equal to 180 degrees. Why 180? Because the circle contains a triangle, and the triangle is 180 degrees. So we solve this, and we find x to be 7. But I asked for the measure of angle F. So if this is F, this is H, and this is G, what one would I use to find F? So the measure of angle F would be 4 times 7 plus 2. So therefore, the measure of angle F is 30 degrees. Now we could easily find the other one, because if this is 90 and this is 30, then this has to be 60. But it didn't ask for that. That's just extra information. It only asked for the measure of angle F. Okay, so your homework from this section will be given. I want us to do 1 through 6, 8 through 20, 23 through 35. And this is all coming from page 727 and 728. And then let's go ahead and add to that over to page 730. Let's do 55 through 61.